Okay, so shall I start?
Yeah.
All right. Okay, so very good evening, everyone. So it is with a great pleasure that I welcome you all to today's episode of our Research and Development podcast series. We are honored to have with us Dr. Angan Sen Gupta, an esteemed academic and researcher whose work has made a significant impact in the field of chemical engineering. Dr. Sen Gupta currently serves as Associate Professor in the Department of Chemical Engineering at IIT Jodhpur, where he has been a guiding force for innovative research and academic excellence. IIT Bombay, a testament to his dedication and expertise in this complex and ever evolving discipline. So, his journey from a dedicated scholar to a distinguished professor has been marked by numerous achievements, both in research and teaching. So, today we are eager to delve into Dr. Sen Gupta's insight on cutting edge development in chemical engineering and the challenges facing the field and the role of interdisciplinary research in the driven innovation. So please join me in giving a warm welcome to Dr. Angan Sen Gupta as we look forward to an enlightening discussion on the intersection of research and development in chemical engineering.
Thank you for your warm welcome. It's a great pleasure to be here and discuss with you a few things and your audience if they have any comments.
Uh, I'm finding difficulty to hear you properly.
You hear me now?
Yeah, okay, fine.
Hello. Yeah. Thank you, Sanjana, for your warm welcome. And I hope this to be a fruitful discussion for you and your audience. Thank you.
Thank you so much, sir. So, sir, we'll be having this fourth episode with you, and I'll be asking some research-related questions. That too
Yes.
also towards the development. As we discussed earlier, that we'll be asking the question related to your field only, not more than that. Just give me a second. So I'll be asking a number of questions. So as per the time, as we have 30 minutes for the question round, so you can continue with the discussion like that.
Yeah.
Okay, sir. Okay, so my first question is, since you have done your PhD from IIT Bombay, so your PhD from IIT Bombay laid a strong foundation for your career, right? So how did your doctoral works shape your research interest and methodologies today?
Uh, but before starting my PhD, when I was doing my master's as well as BTech, uh, I had that impression of going for higher studies, which led me to doing my master's from IIT Roorkee, followed by doing PhD from IIT Bombay. And interestingly, all my work, when I look back today, is more of theoretical work background and not done much on experiments, and I am trained to do theoretical work, simulation work. In IIT Bombay, under the guidance of Professor Jhumpa Adhikari, I completed my PhD on molecular level simulations, which till today I am continuing in understanding various sustainable processes like CO2 capture, water treatment, uh, hydrogen storage, fuel cells, and many other applications our lab is looking into, which includes molecular simulations and other theoretical aspects of research.
All right, sir. So, since chemical engineering often overlaps with other disciplines like material science, biology, and also environmental science, so how has interdisciplinary research influenced your work?
From the very inception of chemical engineering, it is meant to be an interdisciplinary. Historically, if you look into it, chemical engineering came across with few people from physics, few from mechanical, and few from chemistry background, and it meant to solve interdisciplinary problems. And today, also, if you look, most of the institutes, like you can say IIT Bombay, uh, has, though it is called chemical engineering, but you you will see faculties from biochemical engineering
Right.
background and other disciplines doing work on nanoparticles,
Mhm.
uh, uh, colloids, which are not as such classical chemical engineering. So my training in IIT Bombay actually helped me to look into various problems which are interdisciplinary in nature, and
Okay.
therefore the theoretical work that we do can be applied across all disciplines. Typically, we work in, as I said, in hydrogen storage and fuel cells, but it can typically be used even for biological systems, even for chemistry-oriented reaction understanding. And we are trying to do those studies.
All right, sir. That is interesting. Sir, nowadays we are hearing a lot about sustainability, right? So sustainability is a pressing global issue nowadays. So how do you integrate sustainability and green technologies in your research?
So sustainability is really a pressing issues,
Yeah.
and IIT Jodhpur Chemical Engineering Department has one of its theme as sustainability, and most of our faculty work in that area. Our lab has also working in those areas, typically in terms of net zero emissions, uh, and applying simulations and computational tools to develop materials, new novel materials, which can actually help in better treatment of water,
All right.
underground water. IIT Jodhpur being in Rajasthan, it also faces this scarcity of water, which can also be tackled in under this theme of sustainability, where we are also working in the area of air water harvesting, which is actually a project in collaboration with DRDO Jodhpur.
Okay. So would you like to add some more?
Uh, Other like okay, so there is also another problem on which we are working, which is on hydrogen storage. Now, as you know, the government of India has already declared the formation of some valley of hydrogen valley, as they call
Yeah.
five hydrogen valley across India. IIT Jodhpur is a part of that, and I am one of the researchers which is in that team, and we are actually looking into storing hydrogen for long-term usage in the depleted oil reservoirs which are present in Rajasthan. We are also looking into another problem of generating pure hydrogen from electrolysis of water. So these are few efforts that we are doing.
Okay. Thank you, sir. Sir, since most of the student will going to see this podcast recording, so looking at your academic journey, so could you discuss some key challenges that you faced in your research and how you overcome them?
Uh, Key challenges, see, as a PhD student when I was in IIT Bombay, it was very easy going because the lab was well set, and few of our batchmates, three of us joined together under the same supervisor, and all of us are we have well-defined problems and we started working. Though at the end, as in your PhD journey, you are meant to deviate a little and bring out some nuances in your work. That is being done. But being a well-established lab and a well-established IIT, well-established department, we did not face so much challenges. But as we graduate and entered into our own academic career, uh, we face few challenges like developing your own lab, which really takes a lot of time, a lot of persuasion and commitment from your PhD students, master students, and other faculty colleagues of the department. Uh, then, since we are working in computation area, finding setups of high performance computation and then training your own students, at least the first PhD student, training them to be very versatile in using these high computing facilities, and then moving into new area of work. Though typically most of us who do PhD tends to give a problem to their first PhD students, which are more or less related to their own PhD topic.
Okay.
But at the end, you need to actually expand your area and field, and then looking into various problems which have some societal impact. So this is a challenge of finding key problems which can be addressed with the background that we have, and at the same time, it should have some advantage for the society.
All right, sir. It's actually good for knowing this all. So, since you mentioned about the computational modeling in the chemical engineering, so what do you think? What role does computational modeling play in advancing chemical engineering research, and how do you utilize it in your projects?
Chemical engineering, by its very nature, starting from BTech itself, we were trained to use mathematical models even in our courseworks, which gets amplified as we go along and do my master's, and in my PhD, we use molecular simulations. So traditionally, the traditional chemical engineering uses deterministic kind of models, which are well established and are being utilized over various fields. And if you can look back, I mean, we have this CFD softwares like ANSYS, and then we have COMSOL, then Aspin, which actually deals with plant design and all. So these are actually in the course curriculum of a chemical engineering. Now coming to the molecular simulation, which is a very specific area where we deal with time and length scales of atoms and molecules.
Right.
And using these, we can actually help material scientists to design new materials. Say, for example, for CO2 capture itself, we can design new materials so that CO2 can be captured from industrial flue gases. We can design materials for treating water and various other applications. Even as we already discussed that chemical engineers are now are also looking into problems of biochemical engineering in nature, where these molecular simulations play a wide role. Understanding protein behavior, their structures, their conformations, how drug molecules interact with them. Apart from that, even one of my PhD students is actually working in an area of space science, where we are developing some material for space astronauts. It can capture water and CO2 and measure blood pressure. So it's essentially an e-textile kind of thing, where the astronaut wear the garments, and from there it has the sensors which can predict all these things. So not going into much details of it, molecular simulations also help in predicting those properties of those materials, can help in doing those things.
All right, sir. Interesting. Now I'll be asking some developmental oriented questions, since we have covered up most of the research oriented questions. Sorry, sir. So, how do you see chemical engineering contributing to solving global challenges like energy, climate change, and resource scarcity? Since you mentioned about your one of the project, one of your PhD scholars already doing it, but there are other aspects also globally.
Yeah. So, in fact, the problems that are faced by the world today are really interdisciplinary in nature, and where chemical
Yeah.
engineers actually fit in. Not because those are very much related to chemical engineering oriented subject, but because as a chemical engineer, you are trained to solve those problems in collaboration with other interdisciplinary branches. So the pressing issue, if you see the SDG goals of the United States, one of them is this greenhouse gas emission, where we are actually hello. Hello.
Yes, sir. I can hear you.
Yeah. So this greenhouse gas emission actually deals with CO2 capture, uh, then volatile matter capture, other toxic gas removal from air, where we are actually working, and most of the other institute where there are chemical engineers, they are also working in these areas, and people are developing new prototypes of these processes for greenhouse gas capture. Then also, like as I told, this Hydrogen Valley project, this is also a very ambitious project where we are actually wanting to demonstrate pure hydrogen production from electrolysis of water till its utilization into automobile industries for producing ammonia and
Right.
other sectors. So here
Okay.
also we are also working with other interdisciplinary areas, and chemical engineering, not only from the perspective of hydrogen production and storage, but also from the safety aspect of the plant
Okay.
that is being set up, plays a vital role.
So we are considering that with the upcoming time, so we can see the changes and also solving the problems that are expanded globally.
Yes. Yeah. Not only these, the another very apt problem is the water treatment. Though there are already established techniques for treating polluting waters,
Right, sir.
but day by day, more and more pollutants are coming in, which requires niche techniques to remove them. So that is also an open area where chemical engineers can work. Then this minimum use of plastics and polymers, okay, which causes a detrimental effect on environment. There also chemical engineers can work tremendously and uh, develop prototypes, and as well as can involve into making up startups.
Okay.
Okay. Yes, even there are startups which are actually owned by chemical engineers, even looking into AI application for sustainability. And IIT Jodhpur chemical engineering department actually works in such projects also.
Okay. So, could you elaborate that how research at IIT Jodhpur is bridging the gap between academic and industry in chemical engineering? You can interlink with the other aspect as well.
Uh, IIT Jodhpur, our curriculum is very versatile,
Okay.
and we do have the traditional chemical engineering subjects in it. But apart from that, we have new upcoming subjects that are being introduced, like AI in chemical engineering,
Okay.
then molecular engineering, uh, then sustainability, okay, AI for reactor control systems, and various other courses. So, and IIT Jodhpur also have a very strong initiative of treating students and encouraging students to do entrepreneurships and open up startups. Also, the BTech projects, MTech projects can be done as per the curriculum of IIT Jodhpur with industry partners. Like two of my MTech students have actually worked with an industry where
Got
we
it.
were working with the implementation of AI for the safety of a petroleum industry.
Okay.
So there are various other colleagues who are working in a similar industry-oriented projects. Therefore, giving a more real experience to the students of solving real life problems.
All right, sir. That's great because nowadays people sometimes care about that we are not good at academia. Should I go for the PhD or not? There's also a barrier.
Yeah. So essentially, if you look at our lab specifically, we are actually not doing very academic oriented problems. We are
Okay.
solving problems which are really having a societal impact and required for industries.
All right.
Uh, Even the chemical engineering department at IIT Jodhpur as a whole is working towards this direction only.
Okay. That's really interesting, sir. So I'll be having like last two more questions. Yeah. Uh, since the development of the novel materials and processes is integral to the chemical engineering, so what recent breakthroughs have you witnessed or contributed to in these area? Since you mentioned the nanotechnology as well here, so
So again, there are what's been going on across the globe. Uh, we are developing materials for CO2 capture. We are developing materials, uh, not developing materials, but essentially understanding the chemistry of uh, materials, underground materials of oil reservoirs, so that oil can be extracted from depleted oil reservoirs, essentially the enhanced oil recovery that we call. These are few aspects that our groups are working on. Some other problems that my colleagues are working on are use of polymers for agricultural purposes, developing the soil with polymers. One of our colleagues is also working on developing new process for water treatment apart from conventional RO, because as we know, this RO requires a lot of energy, which is
right.
energy extensive, and the output that we get is, as compared to our energy input, is very minimal, and there are a lot of waste that is being generated. One of our colleagues is actually working in newer technologies for treating water.
All right, sir. I think this conventional RO method might be take a good place for that, in trapping the more
Yeah, and
pollutants.
these techniques, these new techniques that is being developed has actually been installed in few of the rural schools of Rajasthan. They have been
Okay.
used.
That's really, I think it would be a great breakthrough for that. So what do you think, the very last question for you, and then we'll near to end the session. So, what do you think is the role of artificial intelligence and machine learning in revolutionizing chemical engineering R&D? Since you mentioned most of the things already, so just a brief about it.
Uh, Presently, what is happening is students are using uh, this AI tools as black box, which should be actually being stopped. One of our professors in IIT Bombay actually used to tell us this using software as a black box is highly detrimental because you don't know what is being coming out and you don't know their analysis. So that has to be prevented. But coming to your question, how it can help, we as a chemical engineers, uh, since we are trained to work with complex mathematics for process industries, there AI can play a heavy role, not only by simulating the processes, but also help us to dig out correct data that is required for the safety of your plant.
Okay.
Because as we know in industries, there can be a lot of sensors here and there, but some of the sensors may be malfunctioning.
You're right.
And then cleaning up those data, which can be easily done by AI tools. One of the problems, what I personally feel is there in AI at the present time is most of the time AI tend to linearize a process and apply the existing techniques. However, chemical engineers deals with completely nonlinear systems. And therefore, we should be really careful while we are applying these tools, understand the process first and the limitations of the tools that are being used. And therefore, we in IIT Jodhpur Chemical Department, we introduced few of the courses where we deal with AI for chemical engineers, which that is an introductory course. And then how AI can be used to control, say, chemical reactor in a chemical process plant. Then we deal with optimization techniques and various other data analysis and modeling, how to use data to do modeling for chemical engineers. And I mean, use of data to do modeling for chemical engineers are well known from age old times. I mean, we deal with empirical formulas for, I mean, all our handbooks contains n number of such empirical formulas. So we know how to use this. So AI can help us to use more data and make our empirical models more robust. I think those are few areas, and obviously, if people are interested in using AI for chemical engineering, they should be aware of the limitations of the tools and the complexity of the problem where they are using.
Right, sir. Because we cannot, I think we cannot completely depend on the AI tools for that as well.
Yes, we can certainly use it to certain extent,
Right.
but not fully with the present day models that are being utilized. But at the same time, I mean, chemical engineering students should be interested to also understand mathematics, because the whole AI depends on complete mathematics
Right.
understanding of a process. And there we deal with linear algebra, differential algebra, probabilistic methods. So chemical engineers should be interested, young chemical engineers should be interested in taking up those courses, mathematical courses, so that their logical thinking and their application of mathematics be useful in proper area.
All right, sir. Thank you so much, sir. We get a great insights about the chemical engineering and a lot about how the academic and also the industrial barriers and also the challenges that we need to tackle.
Thank you, Sanjana, for this wonderful session. Hopefully,
Even
this
though, sir,
will help everyone.
yes, sir, definitely. Even it helped me personally about knowing the modulation simulations about that. Okay. Brijesh, sir, Would you like to add something?
I think it's enough, and we should conclude the meeting. And thank you so
Okay,
much
sir.
from my side also, Angan sir.
Thank you, Mr. Piyush.
Yeah.
Thank you so much, sir, for being with us today. It was a great session with you, and definitely in future we'll also try to connect with you to have a great insight about the particular field.
Sure, thank you.
Thank you so much, sir. Have a good day.